Brilliant. I'm going to kick us off to make sure we have plenty of time to get into some chewy topics. So thanks very much for joining our energy panel at PAW Climate 22. I'm Archy. I'm going to be chairing this session, and we've got three fascinating panelists from a variety of walks of life within energy and machine learning to contribute some hopefully insightful and even better controversial opinions on the topic of the intersection between energy and machine learning. I'll give them a brief introduction and then we'll get going. So I'm really pleased to welcome Olivier Corradi, who's the CEO of electricityMap. He's a statistician, data scientist, and entrepreneur focused on finding scalable solutions to climate change. And he founded a company called electricityMap to organize the world's electricity data to drive the transition towards a fully decarbonized electricity system. And I'm really pleased to have him here because I've personally found the work that they've done at electricityMap very inspirational. There's also lots of great writing Olivier has done on the topic of insights and failings that they've had as a company, which have been really useful to me and other people as we are thinking about climate tech and where it's going. And they're often the first company I point to when people ask, can tech startups really do cool, interesting things in climate? So definitely check out app.electricitymap.org to see their interactive map of live carbon intensity worldwide. I'm also thrilled to be welcoming Sakshi Mishra, who's from Microsoft, and she's got a dazzling CV. She's an autonomous systems researcher and AI engineer, currently a senior AI engineer in the autonomous systems group at Microsoft. And before that, she was leading several projects at the National Renewable Energy Laboratory, including a focus on developing energy forecasting with deep learning. And before that, she had kind of meaty grid planning experience with the American Electric Power. So she's got the whole span from utility scale up to the tech company. She's got a dizzying number of awards, including the Forbes 30 Under 30, 2022 honoree, recipient of the Clean Tech Innovator 2020 Award from the Clean Tech Energy Leadership Institute, the Distinguished Alumni Award from VIT University, and finally the NREL's Chairman's Award for Exceptional Performance. And she's written many journal articles, conference papers, and book chapters that you can check out. And finally, Matineh Eybpoosh, the CEO of gigElev. She's a serial entrepreneur. She was just telling me that she had barely sold her last startup before she was founding the next one. No time for a rest when there's so much to build. She's got more than a decade of experience in leadership, building ML and optimization solutions for energy systems, for energy markets, as well as distributed resources such as batteries and EVs. And gigElev is a software company that works on the integration of electric vehicles to the grid. And prior to that, she founded and sold a company called WhatLearn, which made AI-based software for grid-scale batteries. And she has a PhD from Carnegie Mellon. So thanks very much all for joining. And I want to start with a question for everybody, which is, should we electrify everything? Is that the right thing to do? Does anybody have a strong opinion about that they'd like to share? Everyone's smiling, but nobody's unmuting.
I'll go.
Fantastic.
So the short answer is yes, but let me explain a little bit. I think what we should do is cut our dependence from fossil fuels. I have two reasons for that. And both of them are related to make the world a better place, livable place for us and next generation. One of them is climate change, and everybody, I hope here, agrees that fossil fuels are bad for climate change. The other one is geopolitical reasons, because I'm coming from a background, coming from Iran, a country that it's because of its oil and gas resources have been the center of a lot of tension and of powers, and usually with not good intentions. And the cost was paid by people living there. So I wish that my country didn't have oil and gas. I wish my country had a lot of renewable energy, and so every other country around it had relied on sustainable renewable energy. And right now, today in the world, we are seeing other examples of how dependence of, for example, European countries to gas and oil is causing some geopolitical complexities as well. So for those two reasons, climate change and geopolitical reasons, that I think we need to get away from fossil fuels, and I think electrifying everything can be a way to do that, as long as we move not only electrifying everything but also cleaning the supply side of the energy. So I guess like my easy answer would be yes.
Is there a risk that we move from a concentration of power from fossil fuel producing states to a concentration of power with big companies who can do machine learning really well, like Google and Microsoft?
Yeah, go ahead. I don't want to be the only one.
Actually, you're at Microsoft.
I throw away the controversial like kind of topic. So there we go.
Okay, so I think I'll first quickly wrap up the first question you asked. So my answer is yes as well. And as Matineh was pointing out, it's essentially about reducing the problem space. So right now, what we want for climate change is reduce the carbon emissions from all sectors of the economy. So we are going after transportation separately, then after generation, large scale generation, then buildings, right? So if we electrify everything, then the problem space is boiled down to, since electricity is the source of energy powering everything, we have to clean up the generation. So that kind of simplifies the equation that everybody can focus on making sure that 100% renewable supply for the whole world. That's the goal we are going after that. Instead of like building sector, we have to decrease it. Vehicle sector, we have to decrease it by deploying more electric vehicles. So those problems essentially will simplify if we electrified everything. So that was the first answer. And the second question about the concentration of moving from oil and gas to big companies which can just do ML kind of thing. So I think the way to look at it is these big companies are not really just going, okay, so I have to sound, I am not advocating for the company I work for. Essentially, like that's not the goal here, but the point is, be it AWS or Azure, whatever the cloud service provider, and they are essentially providing an infrastructure for AI to happen easily. So there can be more startups, there can be utilities or national labs, so different players. These big tech companies are essentially making it easier for other players to come in and employ AI solutions. Because if you were to build all the AI infrastructure ground up within the company, the work, the talent, the amount of resources needed is way more than if you are able to jump off of some cloud infrastructure, which is giving you basics of that. So to me, that's how I see it. It's not like just shifting the power from oil and gas to big tech doing AI, but it is actually shifting the power to a decentralized manner where tech companies can come in and help, but won't be like the central hub of everything in that way. So yeah, probably a controversial point, and would love to hear what others.
Actually, yeah, like to your point a little bit, I think like coming from an entrepreneur background, I think it is a little bit to entrepreneurs in this space to also, I mean, coming from someone who sold a company, I might sound like a little bit hypocrite here, but like I see a lot of companies in this space that are being built just for the sake of being acquired by big companies like bigger like giants, and not to sound inappreciative of like these big tech companies, but the culture is different. It is not entrepreneur. It is not like, and the more these acquisitions happen, the less of competition we see. So I think there's also it's everybody's job. Of course, it's not only on the shoulder of entrepreneurs. If entrepreneurs don't see enough support, they have to find an exit. But I think like generally, if the environment is in a way that like there are more and more companies like that that are competing, and there's a good competition environment, that they are not all absorbed by these big powers, that most of the time they just disappear after acquisition. So I think those phenomena that you're like talking about, we would see less of that. Again, like I sold a company, so I'm not like, I'm guilty of that myself, but.
I just want to go back, if I may, on the electrification piece, because I think that's I have actually a little bit of a different point of view. I think it is dangerous to electrify everything. I mean, of course, in the first approximation, electrification is one of the key solutions to enable us to go away from fossil fuels than to electrification with lower carbon fuels or lower carbon technologies in general. But I think if I take an example of, for example, a very efficient diesel car, and if you substitute that by an electric vehicle on a grid that's not fully decarbonized, you might actually end up with more emissions. And I think we have to remember what got us in this mess in the first place. And I think in general, it is the fact that we had uncontrolled growth without properly quantifying the externalities associated. So all the damage that we're doing and all the non-renewable resources we're pulling from the earth, fossil fuels in this case, we need to make sure that we actually minimize it. And sometimes the amount of infrastructure we need to put into place by building the electric system can actually counteract what we're trying to achieve. So just to say that actually this is where data can help, because you want to make sure that from cradle to grave, on a life cycle, you make sure that you reduce your emissions. And actually brings me to the second question that was asked, which is who ends up holding the power, I think. Where is the bottleneck after this transition? And I think there is a transition from fossil fuels companies to suddenly metals. And all the metals that we are going to use that are the cornerstone of this transition can represent some dependencies, which changes a little bit the geopolitical balance, because we realize actually most of the metals we need are located in a few countries around the world. And I think that's also an interesting point. So I'm coming a bit more from the physics perspective, although I really appreciate the points you're making about entrepreneurship and agility. That is also very needed.
Yeah, I'm very pleased to hear you bring up supply chains, because I work on the embodied carbon in supply chains. Do you think that, well, actually, I'm not going to go down that angle because it's too self-indulgent. I'll switch tacks. So in terms of geopolitics, one of the things that countries can do to achieve a global transition to clean energy is by sharing energy in more effective ways. Olivier, I think Denmark is often held up as a prototype for how this can work well and how one can achieve high grid penetration of renewables without having blackouts. What role can ML play in that? And maybe you could give a little bit more about the Danish context for everybody's benefit.
So maybe to give a bit of context about Denmark, what happened is that there was a very strong political will to get away from fossil fuels after the oil crisis that we got, which meant a lot of taxes on electricity, but also a lot of investments in renewable energy and wind power specifically. The reason why it was successful is that Denmark is located very close to Norway, which has mountains, and therefore a very good ability to have dispatchable low carbon electricity through hydropower. And so this means that when the wind is not blowing in Denmark, we can then import from Norway and Sweden in order to alleviate the lack of electricity that we might have there, or low carbon electricity. Where ML can play a role, there's two big pieces to that. I think the general shift that we're having with very high new renewable penetration like wind and solar is that suddenly all of the uncertainty that you have from the weather gets incorporated into the energy markets, and that volatility needs to be controlled because it ends up being operational risk for blackouts. So ML, in general, forecasting technologies can be extremely valuable, because if you can forecast much better the amount of wind that is produced, you are forecasting exactly the need for backup solutions, whether it's interconnectors to neighboring countries, or the need to spin up some often dirty generators at the last minute, because you haven't taken that into account. So I think there's the forecasting angle. And then there's also understanding a little bit the sensitivity of the grid, what we call marginal analysis. So understanding if you do a change on the grid, whether it's operational or more long-term planning, like installing a wind turbine, what is the effect that this will have on the grid? And the grid is so complex, has so many higher dimensions, that it is actually quite useful to use ML for these tasks and learn from historical data and see historically, how did the grid react when we were in these types of situations, a lot of wind, a cold winter, low reservoirs, high energy prices. How does the grid typically react, and what's the best solution or decisions we can make? So I think these are two examples that we see on our end of how ML specifically can help integrate a lot of renewables in a system like the Danish one.
Fantastic. And Matineh, do you see electric vehicles becoming part of that ecosystem, helping to provide some of these services and balance out the volatility in the grid that Olivier mentioned? Is that something gigElev is looking at?
Definitely. That's definitely something that we are thinking about. In fact, the whole reason I started gigElev was because I come from an energy background. I'm not like a mobility person. I worked with batteries. I know how important batteries are for stability of the electricity grid and for penetration of renewable energy. But I also like firsthand saw how actually complicated it is to integrate these like bi-directional like energy resource with the electricity grid. For the most part is because of the way our electricity markets and our electricity grid is set up, like from hundreds of years ago, all based on assuming that the electrons are going to transfer from one point to another in one direction. So after Wassler, my previous company, I was like, obviously I'm going to work on EVs because the next big batteries are going to be on electric vehicles. And we all are talking about these being batteries on wheels, but when you think about it, what have we done actually to take advantage of the fact that these cars have batteries and move? A lot of vehicle to grid solutions that we are right now thinking about, we are actually treating looking at EVs like stationary batteries. You're just like, hey, look, if we park these batteries for hours here and provide grid services, that's great. So why don't you just like install a stationary battery then? I think EVs definitely can be very helpful because they actually move electrons from one point to another. And only other resources in the electricity grid that does that are distribution systems and transmission lines that we know how complicated it is to add just 1 mile of those. So there we go. We have this technology, energy resource that is coming that is moving by default. That is its job, that's its function, to move from one point to another. While it is moving a large capacity of electrons. I guess the way I see it, the only way to electrify transportation in a larger scale, if we see the e-mobility as this mobile energy resource and how we can actually co-optimize it with the electricity grid in a way that these movements are happening in line with what is happening with the electricity grid. And I guess like $1 billion question becomes like, what is the business model there to make this whole like connection happen? But definitely EVs, as I said, we should look at them as energy resources, as mobile energy resources. And you guys know better than me, like the prices in electricity market is settled based on what is called locational marginal prices. Location of electrons matter. And this is what EVs do. They move electrons from one point to another, and we should take advantage of that.
That is a really startling idea. That's the first time I've heard anybody talk about mobile vertical to grid in that way. Digging into that a little bit, like, are people driving big enough distances for this to make sense? Like, nobody's driving from Norway to Denmark when the wind's not blowing, right?
Yeah, is that question to me?
Yeah.
Yeah, okay. Yeah, so the way, like, imagine, like, while you are plugged in and parked, there are a lot of solutions right now that integrate you with the electricity grid through a third-party app that helps you interrupt your charging based on what's going on in the grid and etc. We have those solutions now. But then the moment you start disconnecting and moving on the road, and you are on the road, you are not integrated with the electricity grid. But EVs are software-defined vehicles. They have all the means that we want to actually be communicating with their environment and transferring data. While you're moving in the road, so many things might have happened. As you said, there is like excess generation somewhere. You could actually charge your car to get advantage of that excess wind generation. There is an outage somewhere. You could go and help like providing energy to that outage. So the frequency of the electricity grid is like tripped offline. You can actually be part of that solution. So I feel like we should not be constrain ourselves, but when and where these cars are parked, and we should find ways to actually push the mobility to be a little bit more in harmony with the electricity grid. Like that I guess is the point.
I think to add to your point, you actually make a very good point. If we pair that with the autonomous driving field, then the moving electrons, it's like it's not tied to a human behavior at all. The car is parked as long as software instructs it to move around, it can move around and do the job which you're saying. So when these two technologies come together, autonomous driving plus V2G interaction, that can, and we are not talking 5%, 10% penetration. When it reaches more than 50% penetration on the grid, on the road, then we'll see like the whole phenomena happening at scale, which is what we want. So yeah, that's, I think, very helpful point.
Wow, I have never thought about the grid in that way. That's really exciting. To move on from one hot topic to another hot topic. So blockchain, I've struggled to wrap my head around the role of blockchain in energy. And there might be applications to figuring out who is using which electrons and whether those electrons are renewable. And I was wondering if you guys had any insights onto what blockchain is useful for in energy. Is it useful for anything? Is it a red herring? Sakshi, maybe we can start with you.
So let's talk with respect to an example of RECs, renewable energy certificates or renewable energy credits, as they call it. So this is kind of the topic. All the big corporations, not all, like majority of the big corporations claim their sustainability goals using RECs, this concept of renewable energy certificates. So when we talk, what are these? So let's get into the fundamental of it for 30 seconds really quick, that these are the essentially whenever a developer or a producer of renewable energy can say that we will be producing such kind, this and this amount of renewable energy in the future, they can sell a REC in the market. So, and then the REC itself, it's called unbundled REC. So you put it out as a retailer, like retail market, and anybody can buy it. But then now, like, was that electricity really generated? Was that plant even built? And if it was built, was that electricity generated at given point in time? Because it's intermittent electricity. All these variables are just floating around. The transaction has happened. We create, like, as a developer, let's say I'm a renewable energy developer. I have created a REC. I have sold it. Some corporation has bought it, and it's all happening like a market layer. We are not talking physical electrons here, right? And then, so all those things don't get accounted for, that did it really happen? So in this way, if I'm on East Coast, I'm selling a REC, and West Coast, somebody is buying it for 6 months in the future, that I'm saying 6 months in the future, this will be produced, this is the REC, and that's being bought. So how can we really wrap our head around, was the thing done? The goal was to reduce carbon footprint by showing that this electricity generated from a clean energy plant was used. How do you trace it all back, right? So that's the fundamental problem which we want to solve. And can blockchain be the solution? That's our next question then. So the answer is yes and no. So, so let me address no first, because a blockchain has, like, as a technology itself, it has so many variations. Should it be a private blockchain, a public or open source kind of blockchain, or consortium blockchain? Right? Depending on what kind of solution you're using, the design of blockchain-based solution can make or break the deal here. So that's the no part. So and yes part, yes, blockchain can help, because the fundamental strength that blockchain offers is this time-stamped immutability, right? So once we can have this digital record, which cannot be modified by anybody, right? The immutable digital record timestamp that today, June 2nd is when I'm selling it, for December 3rd, and this is the record, and that gets carried over. It will not be changed, right? So if we have that kind of accounting put into place, then it becomes way easier to trace back that whether a sold REC, the renewable energy credit, was actually worth it in terms of reducing the carbon footprint using that much renewable energy generation, that it was like really, it did what it was supposed to do. So yes, blockchain can be a solution, but there are so many variations into implementing it that unless it's designed with so much deep thought about how will blockchain interact with all the stakeholders, who gets the right to add to it, how do we ensure that nobody can modify it, it's immutable in the form of Bitcoin and Ethereum. No, I'm talking about the consortium kind of blockchain where there are few stakeholders which do have right to add information. So maybe they can modify it too, right? So depending on what, so I think the answer is yes and no. It is possible to use blockchain for solving this problem, but there is a lot of fundamental work which need to be done in terms of designing the blockchain-based solution to make this happen.
So Olivier, you spend a lot of time worrying about where electrons have come from and where they're going. Is this part of your plans?
So I think there's two pieces to that. There is how do you do effective traceability, and then there's what is blockchain and what can it solve. And I think we first take the piece about blockchain. I think from a software engineering perspective, blockchain is a distributed database. And if you look at it from the prism of its distributed database, a distributed ledger, there's many ways to build a distributed database with immutability constraints. And I think blockchain is just a subset of that. And if you look at it from that prism, then I think most of the variations I've seen of a blockchain implementation ends up being more expensive ways to actually implement a distributed database. I think what is highlighted typically in a blockchain is the fact that you have this immutability of records. But I think something that we often forget is that you always need an entity that's going to take an information from the real world and put it into the blockchain or put it into the database. And that step, in the blockchain world, we call it the oracle. That step is a step where you will always need an entity to be overseen to verify that they're not putting the wrong number in. And so the technology itself will never solve that problem. It's a governance problem. So that's where I think blockchains as a technology can be a bit overhyped because they're not solving the governance problem. And if you focus more on the traceability and the governance problem, yes, there's absolutely solutions there, and we have problems, I would say, because recs are not at the granularity that is required to be effectively driving the transition. You have a whole movement now that's called 24/7, when instead of looking at renewable energy credits at the certificates at the yearly scale, we're looking at them at the hourly scale to make sure that you have a more credible traceability. I won't go too much into details into how you actually track origin of electricity, because that could be like a very, very long discussion. But suffice it to say that in our experience, the problem is more related to the incentive mechanisms that we are giving to companies, and how do we verify that these incentive mechanisms are actually driving real change. And I think that's more where the problem is, and it's less on sort of the lack of technology or data systems to be able to track things, because now you actually have a lot of transparent data out there that can tell you exactly what power plants produced in a given hour in a given place.
So maybe I can ask one question. I have a little different thought there. So you mentioned it's a governance problem as much as it's not the technology problem. But don't you think that if we employ the blockchain solution in a way, let's go with proof of stake algorithms. So there are different kinds of like consensus mechanisms which are used for the context for the audience. So the question to Oliver is, if we went with, let's say, proof of stake, and those are the entities who are allowed to make any changes, don't you think that could be the solution to the government's problem, where the stakeholder themselves are incentivized to enter the right data in some way?
Well, so the question is, what is their incentive to actually enter the right data? Because I think we're sort of conflating both in the blockchain world, whereas typically in an organism, like if you take Visa for a credit card transaction or any other application, you have an entity responsible for the technology where there's a consensus algorithm to make sure that no one is tampering the system and that one specific actor is entering an information that no one agrees upon. And so you have like Paxos algorithms and other types of algorithms to check that you're not mutating the data. But then on the other hand, there's a governance problem or issue in the sense that all the actors need to agree, and furthermore, their agreement needs to be representative of the physical reality. And I think it's that last piece that is maybe not mandated in a blockchain system. Yes, you can have consensus on the parties, but you are not sure that the consensus is to game reality, so to speak. And that's where you need the governance issue to come up. You need the board, you need someone that verifies that, that you're not entering wrong information in the system, basically. And that is a problem that is not a technology problem, it's more of a incentive problem overseeing governance and so on.
I see. It's the seller and buyer kind of dilemma, that sellers can have all the consensus together, but that doesn't match with the buyer reality.
Exactly, yes.
Okay.
I thought we might have found a genuine point of disagreement, but it seems like you've resolved it already.
I'm trying all I can.
Thanks. Matineh, did you have anything to add to that?
No, I'm not expert enough to have a disagreement. So
Everybody's allowed an opinion on blockchain. You don't have to be an expert.
I'm just learning about blockchain.
So switching gears slightly, Olivier, you mentioned forecasting, and it seems like a lot of the big events we've seen in energy are these sort of black swan events that are very unpredictable, like the war in Ukraine. No algorithm is going to be able to identify these events that have such a huge impact on energy markets. Is there anything within the ML toolbox that helps us deal with this, or do we just have to say when the world changes like this, we've got to go back to the drawing board? That's a question for everybody, but Olivier, maybe you want to kick us off.
I can give it a shot. I think it's an extremely difficult question, and it goes back to how do you make forecasts that can be robust in very difficult situations. And I think fundamentally the way that we've been looking at these things is that you have two kinds of features or explanatory variables that you can put into your ML system. There are features that, let's say, can depict more statistical correlation, and there are features that are more structural, fundamental, that explain to you how the system actually works. And the example that I have in mind is if you have a model that correlates, I don't know, wind power production or solar production to the hour of the day, for example, that's different than if you actually correlate it with the weather conditions. And these are the fundamental principles of why a solar panel is producing electricity. It's not because, you know, it's noon and it has to produce electricity. It's because the sun is shining. And I think the more you can relate your machine learning models to fundamental structural underpinnings that can be explained and not black box models that are just doing statistical correlations, then the more robust the system will be, because you're actually understanding how the system works and not just making correlations that will inevitably fail or be invalid the time that the system strongly changes. And I think what we're seeing with Ukraine, I don't have, unfortunately, a particular example of a machine learning model that would have, sustained that wild of a change. But it's quite sure that you try to understand the underpinnings of the grid, then you can make predictions about what would happen if you disconnect a larger region, for example, instead of just saying, we expect this interconnector to, operate independently of what happens structurally on the grid. I hope this makes sense.
I think so. So I've seen a lot of people who started out modeling the physical aspects of generation with the intention of producing a model eventually of price. And then they kind of gave up. They were like, let's just predict price already, because all this weather stuff's already priced in. And you're saying those kind of models would fall over because there's no structural integrity to them.
I guess you have a spectrum between both of them, and it depends on what you're considering as input and output. If you're considering price as input, then someone will need to produce that forecast. And the question is, how will they then produce that forecast, right? I think just in general, the more robust machine learning models are the ones that are having a bit more of an understanding of the system, instead of just having built correlations over time that might end up being, obsolete when the system changes too much.
If I can add something to that. So have in the past, based on my experience, these kind of unpredictable events happen way more often than the Ukraine case in the electricity grid. For example, a power plant can trip offline unexpectedly because of some damage, or transmission line can be broken by a bird, or a battery can catch fire, or something that you didn't expect to happen. So your model, like your historical data, hasn't seen it. And based on my experience, we So too often of those that we started to realize that, okay, we need to address these things in our model one way or another. Like we cannot every time these unpredictable things happen be like, oh, this model doesn't represent the grid anymore. So one of the things is that again, because they happen more often, you can actually kind of learn from them. So similar, like you can classify these kind of events into like similar clusters. That, okay, like when the transmission trip offline in this area, it's similar to, I don't know, when this happened in these areas, and kind of like have a little bit better of like foresight. But yes, we cannot predict these things because by nature they're unpredictable, but we can predict what comes after. So that is something that we have been doing and using this like frequent occurrence of these kind of situations, basically predicting, okay, this power plant tripped offline, what comes next? So if you have that visibility, if you have that forecast of, okay, how the world around that looks like after this event happened, I think it can be a game changer. You are way ahead of the game compared to others who don't have that visibility.
Yeah, that's a really good point. So not trying to predict the event, but trying to predict what follows.
What follows, yeah. And take advantage of the fact that these events are actually more frequent than you think of, yeah.
Yeah. And if I may jump in, I think that's an excellent point, because we often tend to forecast for the mean and try to do point forecasts of, say, like, does this event happen or not? And I think when we're looking more at the distribution itself, and we're looking at the quantiles of the distribution, it starts becoming more interesting, because you can start classifying the situations where extreme events are more likely to happen. And you can even build systems that are dedicated to try to predict the likelihood of extreme events to happen. And I think this is more interesting to quantify the uncertainty around an event, instead of just having the predicting an exact price, for example.
I think one thing I can add to it is, going forward for the machine learning community to be able to build better solutions, one thing that can help is having the data made available, first captured and then made available. Once such events happen, usually it's like event gets noted about, but nobody will measure or keep a record of the voltages and currents and how the grid configuration was impacted. If that data gets accumulated over a few years, then supervised machine learning algorithms can be of some help in making predictions about what to expect when such things happen.
That's a great point and a great segue to my next question, which is about how we unify these two worlds of the grid and the engineers who are used to working with the grid and making the data available from the grid, with machine learning people who often don't have such a deep understanding of the infrastructure or the backgrounds. So this seems like a field where just kind of running in with your deep neural network is a bad idea. You've got to spend time with people to understand what's going on. Have you had experiences about the best way for machine learning people to acquire that expertise? Or do you think I'm wrong? Do you think actually, with enough backprop, you don't need to know anything about the real world?
I go first because of some experiences that I have. When I started my work at a startup called Quantera that was doing machine learning for predicting electricity wholesale market, I was a machine learning expert. I worked on energy systems, but energy system is just a system, it's equipment. I worked on the state of health of those energy systems, but I didn't know anything about the electricity wholesale market. I only became a good data scientist when I became an expert in the electricity grid, when I learned like in and out of how it works. Before that, I was just like throwing, what's the expression, throwing dart in a dark. So now I am in a place that I'm actually hiring people for these expertise. This is my advice to everybody who is interested. If you are interested in the energy space, if you want to work in this space, become an expert in it, learn how it works. If you bring a machine learning expert from, I don't know, like a cat video editing industry, and they probably can immediately like come up with some accurate forecast models for you. But as to Olivier's point and others, when things change, these models don't have a knowledge of how actually the system works. When those like kind of things change, oh, like wind was acting different, blowing from a different direction today than we have seen in the before, or something like that, then they don't know, they cannot explain it. If you cannot explain the behavior of your model, you need to learn more about the domain that you're building a model for. So yes, they should talk and learn as much as they can, but they shouldn't be like, okay, I'm a machine learning person and you are a grid person, so we work together. Just learn as much as you can. You should become a grid person yourself if you want to solve problems in that space. I guess that is my 2 cents.
I got some follow-up questions on that, but I want to give Sakshi and Olivier a chance to chip in on that first.
I think I partly agree to Matineh's point that you really have to have some insight into it. Without that, it's not possible. But at the same time, when I think about the scale, in the sense that we need like hundreds and probably thousands of practitioners to come and just start following the energy field and help us out. So it's like practically they may or may not be interested in it at that point. And it also like, so essentially expecting like people who have done, let's say, machine learning for 5 to 6 years, they are so good at it, they can take some data and then they know how to put it all together. There are some barriers if they want to, like, and I guess, so this is something I think you will agree with me that you had to put in a lot of effort and timing focusing on ensuring that you do learn more about energy systems. So in that regard, if you are bringing together a team of people, then probably this recognition of the fact that this is the reality, that if you are not so much expert on a grid, you're not going to be an effective data scientist in my team. But you are a good data scientist in itself, so you are here with us. So let's recognize those differences, and so make the incentives to collaborate better within a team environment, so that they can come together and do things like, instead of having to have this learning curve of three years, they can boil that learning curve down to 2 months of close interaction with a grid expert, and they themselves know machine learning, and then both of them probably like come together. But I think it boils down to how much budget resources do you have for solving this specific problem, and how many people can you bring together? So that's a meta level question.
I guess like what I said is like pretty actually the same thing. I'm not saying like I only hire, or like I think you should be a grid expert in order to enter this. I'm like, if you actually are interested in this domain, don't rely on other people's expertise. Learn as much as you can, collaborate as much as you can to become an expert in this domain. And that doesn't mean that wait and don't build any solution while you're obtaining. It is a hands-on experience. It is like, as you are building it, hey, why my model is behaving this way? Let me go and learn. Let me talk to people. Let me read about it. So don't think that just because you know machine learning and optimization, you can thrive in this space. You should love it. You should learn about it. You should collaborate with people. And yes, there's a learning curve, but it is actually like not that bad. You can actually like very easily observe as you're working hands-on in a problem. You can easily like gain experience in this. So I guess like the only thing I'd say is that don't think like I don't need to learn anything about this space. I'm a very badass, sorry my language, like a machine learning expert, so I don't need to know about the domain. I think it only makes you better if you are very knowledgeable about the domain that you're building models for. I guess like I agree with you.
Yeah, that's where I was headed to. So it's the mindset thing, I think, which you are pointing out, that we cannot go in with the mindset that I'll keep my eyes closed to the whole grid phenomena and just assume because I am a machine learning engineer, I'll do well. I have to have that attitude of wanting to learn, hunger to just understand the field itself better while doing machine learning on top of it. So yeah, again, agreement reads, sorry, Archy, we are not able to make it too controversial here.
Olivier, I'm relying on you to tell me that all I need to care about is convolutions.
No, unfortunately, no. No, though, excellent points. I think I want to sort of share a little bit of a concrete learnings that we've had with electricity map, because what we're doing is in the end that we're predicting the carbon intensity of the grid worldwide at scale for every hour of the year, which means that we need to predict exactly how much production you're going to have for every system. And what we realized by throwing machine learning at the problem is that the machine learning started to learn the errors in the data. Like we realized there's some places in the data where there's a wind turbine that tells us it's producing 10 megawatt hours during a certain hour. And we realize, wait, it's actually producing 20. How the heck do you learn this in your machine learning model? So you need people that will have the expertise about the local markets. And this is where it becomes extremely difficult, especially when you want to do things that are scalable globally. And so in order to be able to do good forecasts, we've actually ended up having to introduce machine learning at the earlier stages of our processing pipeline to make sure that the data is super clean. And now we're even spending time going to the data providers and telling them, what are the guarantees you can give us? And this is where the expertise really comes in. Of course, you also needed to make good features in your machine learning model. But for us, the bottleneck has really been, how can we turn this data that we get in to like high confidence data, and then we can learn from it. But there's too many situations where we've learned from it, and then we're like, wait, did we learn something true or not? And there you need domain expertise and local energy markets expertise.
And you're open sourcing some of your data as well, right? So you've got collaborators all over the world chipping in. So that must become a particular issue or a particular concern.
So actually, that's the reason why we ended up open sourcing things as well, is that we realized we're not going to be able to be experts in every market across the world. And so we're relying a lot on different expertise from different places to give us that information. And right now we are partially open source, so not everything is open sourced, but we're actually looking at opening up more and more data. And probably during the summer, there will be a new, very extensive release of electricity map with historical data as well. And we hope that that will, create some momentum to build even higher quality data inputs to our systems that we can then share with the rest of the world. So anyone else who wants to do ML can do it on a, curated data set that is of higher quality.
That sounds awesome. Eugene has asked in the chat, are there any classes or books for ML people entering energy to like figure out some of these energy system things? Any thoughts on that?
I don't know about ML classes, but usually when I have like someone first coming in, for example, some markets, in US, for example, Texas does a good job. They have like classes like these different ISOs, independent system operators, those who are operating the grid. They have classes 101, kind of teaching you how the market works, how the grid works, like very basics. I usually send a package of those, like, hey, take these classes. Sometimes, in fact, like at the company, we do like lunch and learn time, and we finish one of those courses. So that helps you up to speed with like very basics of how these markets work, and with some terminologies that can be very confusing for someone entering the market in the industry. And then you can take some ML courses on the side, and then boom, you have like ML for energy. I think that is the way to go.
Olivier, do you think that as part of the work of curating this data for electricity map, you can expose it in a more friendly way? Because this afternoon I spent some time on the Elexon, which is the body that provides UK energy data, and it's just almost deliberately unintelligible, it seems.
Accessibility is a huge issue. I think we are looking in our roadmap, I can't share too much, in opening up more data and even thinking about more Kaggle type competitions for machine learning. But to the point of the question asked in the chat, there are actually some Kaggle competitions on wind power forecasting specifically, because that's a topic that I used to work on. So if anyone is interested, it can just Google wind power forecasting Kaggle, and they'll find some data sets they can get their hands dirty and try them out. But I also think that's actually the way that I got into the field. It's just that I took some of this data from Elexon, from others, and just tried to see if I could build a prediction out of it. If you have observed data and you try to build a prediction, then you sort of already have a challenge there for yourself. You don't need to sort of pick back on a Kaggle composition to do this. And then the community in general is very open. I think there's many open initiatives related to energy data. There's Open Energy in the UK. There's as well. I mean, there's a couple of them that we can link to later on. I don't want to list them all here, but the energy industry in general, I feel like is pretty open to being open source on these issues. So I think that's a great opportunity for anyone who's an aspiring data scientist or ML engineer.
There is one resource I came across recently. Somebody wanted to get started with it. It's called Ferc Energy Primer. It's all focused on US grid and markets, but I think that's something kind of comprehensive. They talk about all aspects, so that might be something like the 101 kind of tutorial.
Fantastic. Eugene has also dropped some kind of briefing document that he got from the CEO of Camu when he interviewed a couple of years ago. So we can start to form our energy wiki. On the subject of hackathons, Open Climate Fix, who Peter Dudfield's speaking later today, they ran a hackathon at UCL a few weeks ago on predicting solar generation in the UK, and that was really successful. And they had models contributed by students which were as good as the ones that they've been working on. So definitely lots of potential in the space for that. We've talked quite a lot about energy generation and not so much about energy demand. Do you think that there are roles for ML in shaping demand to match generation more closely? Or is that a daft idea?
Maybe I'll jump in here because I think we operate a lot under the, let's say, vision that because renewable energy resources are intermittent, then what you need to do is to be able to control your load to make sure that it matches the times of renewable abundance. And we've talked a little bit about electric vehicles. I think there are a huge potential to make sure that they both use electricity at the time where it's available, but also at the location where it's available. So this part in shaping, let's say, aligning the times correctly, because we're shifting from this system which was previously production-led, and now it needs to be, or previously it was consumption-led. So you turn the knob on the production in order to make sure that when you turn your kettle on, then you would be able to boil your water to get your tea. And now suddenly the wind is blowing and you need to make sure this wind energy is utilized. And when it's not blowing, you need to make sure that we use less of it because there's none at that time, right? So I think that's one big piece, is aligning and orchestrating. And I think another piece is more in the energy efficiency space. I think there's a lot of missed opportunities because we don't know exactly where the opportunities are. And some of the, like a very concrete project that I used to work on a long time ago is one where we're trying to detect from the outside which buildings are energy efficient, which ones are well insulated, and what are the characteristics of these buildings to realize, is it the insulation that's a problem? Is it the type of heating they're using? Is it the roof? Is it something else? And I think this is also something where open data in general can help create some of these new business cases and new entrepreneurial opportunities for someone to create something in the space. So I think there's energy efficiency, and then there's, utilizing the electricity at the time and the location with lowest carbon. I see these two as very high potential avenues.
Is that the way that you see it at gigElev as well, Matineh?
Yeah, definitely. That is the whole reason gigElev exists, because we think the demand side has a lot to do to make the supply side like clean and stable and resilient. So yeah, as Olivier said, we are using EVs to help electricity grid charge or discharge when or where it is most needed. One of the I guess like areas that I realize on the demand side management we always see is that there's always a compromise. There's always a disruption of whether it is operation or activities of the end users. So I think innovative solutions that can actually make that less painful for the demand side, the less disruption and compromise that we have to impose on the demand side, the more participation we would see on that end, and the more scalable we can do the demand side management. So that is part of the reason that the business model that we came up with at gigElev exists, is because trying to actually make the demand side to want to participate rather than just kind of having to compromise, okay, for the sake of the better good, but yeah, I definitely think that the demand side, and there's a huge market for it. You see it on the electric vehicles, you see on the appliance level, you see on the demand response, and based on like the topic of this panel, which is the application of machine learning into space. Machine learning has a lot to do with that, because predicting the demand, predicting the supply, and matching these two together in with the least cost possible is definitely something that ML has a lot to do with.
I'm really sorry, but I've just realized we are 2 minutes over and we didn't leave ourselves any padding before the next talk. So I need to drop to chair that, but this has been a super enjoyable discussion. Thank you so much for bringing your controversial selves to it with all your expertise. So we better leave it there. Thank you very much indeed.
Thank you.
Thanks, guys. Good to be here.